Okay, you guys, so in this video what we're going to do is we're going to flip the script. So you'll notice what I've given you is I've either given you a graph or verbally I gave you some information. And so our job is to find what is the equation of the circle that's being described. All right, so each condition creates some unique features. We'll take advantage of them, but it basically comes down to, right, can you find the center? Right, and can you find the radius? So it's very much kind of like our equation of a line. Sorry about that. It's like an equation of a line, right? With a slope-intercept, we were looking for slope and the y-intercept. If it's point-slope, we were looking for a point and a slope. If I didn't have one of those things, I worked around and figured out how to get it. It was usually slope. So very similar. Our charge is to basically find h, k, and r. Once I have them, I plug them in. So first one's pretty easy, right? Because I'm telling you the center is at 4, 5, and the radius is 3. So that tells me right away, right? Here's h, here's k, and there's r. So all I got to do is come to my formula and just plug and chug the information in. And I think the answer in my math lab or something will probably look like that. All right, so x minus 4 squared plus y minus 5 squared equals 9. So that was a nice, easy one for us. So what if I give you a picture? Right? How do we find the equation of the thing that's pictured there? Well, again, it's if we can find the center, we can find the radius. So it's all about finding that center. So I think if we kind of visualize, sometimes when we're doing a class thing, I have students actually kind of flipping the pages over, getting that mirror image, that symmetry, if you would, right? But it looks like we're symmetric about that line, about right there, right? The mirror image about that. And then it looks like we're symmetric about that line right there. So it looks like the center, right, is sitting right there at 2, negative 3. And now that I've got that center, it looks like we're 1, 2, 3, 4, 5 out. Verify it. 1, 2, 3, 4, 5 out. 1, 2, 3, 4, 5 out. 1, 2, 3, 4, 5 out. So it looks like r is equal to 5. So there you have it. So we got what we need. So here's h, here's k, and there's r. So plugging it in my formula, we get x minus 2 squared, right, plus technically y minus a negative 3 squared equals 5 squared. And cleaning that up, you will probably see that, right, in my math lab or in answers in the back of the book. So far so good. It's all about finding that HK. So the next one, all right, so we're going to find the equation of a circle that has a center at 1, 1. So they actually gave me h and k, right? So h is 1 and k is 1, but it contains the point 4, 5. So what does it mean to contain the point? Well, that's just another buzzword for that's a solution point. This is a point on the edge. So again, really quick sketch, right? Here's 1, 1, and then 2, 3, 4, 2, 3, 4, 5. So basically, right, we've got a circle that looks like that, right? So there's 4, 5 on the edge, and there's 1, 1. So do you see what we need to do here? We basically need to find that distance, right? What's that distance? So it's basically our distance formula. So we got, I'm just going to call it r though. R is the square root. We've got 4 minus 1 squared and 5 minus 1 squared. And that's 3 squared and 4 squared. 9 plus 16, square root of 25, right, we get 5. So my radius is equal to 5, and my center is 1, 1. And we use the distance formula basically to find that radius. And again, it doesn't really matter, this distance, this 5, is the same no matter what. We actually knew one of the data points, and I use that to my advantage. So putting this all into our formula, we have x minus 1 squared plus y minus 1 squared equals my radius squared, right? Or officially, there you go. So there would be for a center at 1, 1, a circle that has a center at 1, 1 and contains the point 4, 5, there would be the equation of that circle. Not bad, right? So let's try getting a little more difficult. So the next one, we got the diameter, right? Contains the point 3, negative 2, and negative 1/6. All right, so recall what a diameter is. If I'm drawing a, let's go ahead and kind of maybe draw a picture of this. So we have 3, negative 2, right? So there's 3, negative 2. And we've got negative 1, 1, 2, 3, 4, 5, and 6 up here. So there's some circle here. And what we're told is that these points lie on the diameter. So the diameter, right, is this guy. There's the circle that basically connects those 2 points, which means our center point's somewhere right in there. So what are we going to have to do here, right? How do we find the middle point, right, between 2 points? We use our midpoint formula. And so a midpoint formula, we're basically going to average our x values. We're going to average our y values. I think we end up with 2 over 2 here and 4 over 2. We get 1, 2. So there, right, the midpoint is basically our center. Now that I have the center, right, now what I need to do, right, so that center's at 1, 2. I hope I drew that okay. So there's our center. Now I got to find the radius. And you can basically do this 2 ways. You can actually find the distance between the 2 given points, divide it by 2 to get the radius, or you can basically find the distance between this point and this point, or this point and this point. Remember, it's the same. It's the radius, whatever one we want. So how about I just go ahead and use that point and this point. So our radius is going to basically be our x value minus our x value squared plus our y value minus our y value squared, square root. And so I think that's negative 2 squared. That's 4 squared. 4 plus 16, we get r equals the square root of 20. I'm just going to leave it at that in a moment because we're going to square it anyhow. So r is the square root of 20. So what's our equation? Well, here's our center. Here's our radius. So we get x minus 1 squared plus y minus 2 squared, right, equals the square root of 20 squared. All right, and of course when I square a square root, it just clears that out. So I'm pretty sure you'll see that in the back of the book. All right, so almost done. So again, taking situations, making use of some previous knowledge, right? That's a good math whenever we build more math ideas from previous math. So last but not least, a new idea here. We want to find the equation of the circle whose center is at negative 5, 4. So the good news is they've given me the center. So I know h and k. To find the radius, though, we're going to use the information that this circle centered at negative 5, 4 is tangent to the line y equals 1. All right, so that's kind of an odd statement, right? Usually when I'm teaching face-to-face, I make my students kind of think about it and articulate. But since we're 8 minutes into this and you guys are probably getting tired, let me tell you what it is. Tangent in a math setting means a lot of things. The way it's being used here is if I have a graph, let's say a graph like that, and I have a point here, to be tangent to it means that I give it kind of a glancing blow, right? I don't literally cross through it, right? That's not tangent. I basically hit that point on the graph, but I do it in kind of a glancing way. I glance right off of it. So that's what it means to be tangent. So let's draw ourselves a picture here. So we have, let me draw it up here a little bit, right? We have the line y equals 1, so that would be this line right there. 2, 3, 4, 5, 1, 2, 3, 4, 5. And we've got a center sitting at negative 5, oops, negative 5, wrong way. Negative 5 and 4. So there's my center, right? And so whatever this circle looks like, right, let's come up this way, its edge of the circle, right, whatever that circle has to basically be, right, tangent to the line y equals 1. And that gives us a lot of information because that basically means we're going to go up 1, 2, 3, 4, 5. So that tells us that the radius is 5. I got everything I need. So we have x minus a negative 5 squared, y minus a negative 4 squared equals 5 squared. And cleaning that up, that's x plus 5 squared, y plus 4 squared equals 25. So I think that pretty much covers just about anything you're going to see in your homework. We're using the equation of a circle. We use whatever it takes to find the center. We're either given it or we're given it some information. It's usually a midpoint. And then the radius itself is the distance formula. So we have to use that, and we learned a new terminology called tangent. Alrighty, so that wraps up 2.3. As usual, if you have questions, please ask. All right, jump on Canvas, ask for a virtual office hour. Right, good luck on your quiz, good luck on your homework, and I'll see you guys in the next module.